Today we're going to look at the division properties of exponents. We've worked with properties of exponents already in solving problems. We're just going to add to the rules that we already have. So rule number 1. When you're dividing the same bases, you will subtract the exponents. So key word or key phrase, subtract the exponents when you're dividing. Now, you can't subtract the exponents just any old way, whatever you like. You need to go the top exponent minus the bottom exponent. So top minus the bottom. Let's look at this first example. We have a to the 9th power divided by a to the negative 2 power. So we have division here illustrated by this fraction bar, and our two powers are 9 and negative 2. So we are going to subtract the top minus the bottom. Let me show you what this looks like. The top was 9 minus the bottom exponent is a negative 2. So we're going to subtract those two. 9 minus a negative 2. And we already know that 9 minus a negative 2 is 11. So our answer is a to the 11th. Let's look again. Not only will we have bases and powers, but we still got regular numbers coming along. We've dealt with division of regular numbers. So let's bring those into play here. We have 16x to the 4th over 2x to the 7th. Let's take it one thing at a time. Let's deal with just our regular numbers first. We have 16 divided by 2. 16 divided by 2 is 8. Now let's look at our exponents here. We have x to the 4th divided by x to the 7th. So remember, we're dividing, so we have to subtract the top minus the bottom power. So let's do that. 4 minus 7. What is 4 minus 7? Negative 3. Now, we can't leave our answer with any negative exponents. We dealt with this days ago. So let's make this answer correct by getting rid of that negative exponent. That is the only thing that's bad here, is the x to the negative 3. The 8 has nothing to do with this negative 3. The regular number of 8 is like 2 spots over from this power. So only the base that goes with this power is what's considered bad. So let's make it good. We're going to move it to the bottom and lose that negative. Move it and lose it. Now what was good on top was the 8, so we're going to keep it exactly where it was, not touch it. We are done with this problem. Let's go one more, because there can be more than one particular base, just like in this example down here. We have w to the 3rd, h to the negative 4th power, over w to the negative 3rd power, and h to the 6th. So we're dividing. When we divide by the same base, we subtract those exponents. Top minus the bottom. Let's look at the w's. 3 minus a negative 3. So our powers is 3 minus a negative 3. That's what's going on with the w. 3 minus a negative 3 ends up being 6. Let's deal with our h's. We have a negative 4 on top and a 6 on the bottom. So let's go from top to bottom. Negative 4 minus 6. Negative 4 minus 6. Negative 10. Again, we have a negative exponent. It's not good, so we're going to have to make this positive. Let's go with it. The w to the 6th is okay. It has a positive exponent, a positive power, so we're good. We'll leave it right there. But the h to the negative 10 has got to move and lose that negative. Done. The next rule I want to discuss is rule number 2. Now, rule number 2 is normally considered maybe an organizational rule, and this rule is to dissect and distribute. We've seen in the past like power to power, so this is kind of where we're going with this. Notice that I have a fraction, 3 divided by x to the 4th, and this entire fraction is raised to the squared exponent here, this exponent of 2. So the whole fraction belongs to this exponent of 2. This is what I mean by dissect and distribute. Take each individual term that is in here and put that power on it. Watch. On top we had a 3. On the bottom we had an x to the 4th power. So those were the two things that were originally there. Now notice the outside power is 2. That means it's going to go to everything in the problem. The 3 gets the 2, and the x to the 4th gets the 2 as well. So now let's solve this out. Up top, 3 squared. 3 squared is 9. On the bottom, we have x to the 4th raised to the 2nd power. So I have two powers that are side by side each other. And that rule says that we multiply those powers. So 4 times 2 is 8. Simplified. Can't reduce anymore. Look at this next one. Let's get a little bit more elaborate here. I have b to the 3rd, c to the 4th over 2a to the negative 5th power. But all of that is raised to the 3rd power. What are we going to do? We're going to dissect and distribute. I have on top a b to the 3rd. That's one term there. Also, I have a c to the 4th. On the bottom, I have the number 2. Also on the bottom, I have a to the negative 5th power. So I put each individual part in its own set of parentheses. Now I'm going to take that outermost power and distribute it onto each individual term. A 3 belongs to this, and this, and this, and that. Dissect and distribute. Goes to every little thing that's there. This is a lot easier seen if you write it out. So let's go with it one at a time. b to the 3rd raised to the 3rd power. Power to power means to, you got it, multiply. 3 times 3 is 9. c to the 4th, all to the 3rd power. Again, power to power, multiply. 4 times 3 is 12. That's on top. On the bottom, we've got a regular number of 2 to the 3rd power. That's 2 times 2 times 2. 8. a to the negative 5th raised to the 3rd power. Power to power again. Let's multiply. Negative 5 times a positive 3 is a negative 15. So we've dissected and distributed that outermost power. Now let's make sure our answer is clean. And I'm noticing right now that I have a negative exponent. No good. It's bad. I've got to make it good. So we're going to move it and lose it. This whole thing has got to go up to the top. So I'll rewrite my answer right here. On top, b to the 9th, it was good. c to the 12th, it was perfect. That a to the negative 15 down below is now being moved to the top. Move it and lose it. So all of my letters ended up being on top. The only thing that's left on the bottom is this number 8. We are done. Can't simplify any more. One more rule. Let's go to rule 3 and we'll be done for the day. Rule 3, when a fraction is raised to a negative exponent, you will switch and swipe. And then work the problem according to the rules that are at hand. If you have negative exponents, if you've got power to power, just you have to see what's there given after you fix the outermost exponent, which is negative. So again, when a fraction is raised to a negative exponent, you will switch and swipe and then work the problem. Take this one example here. We've got negative 7a over b to the negative 1. And that entire fraction is raised to the negative 2 exponent. This is causing the problem. This fraction is raised to a negative exponent. When the outermost exponent of a fraction is negative, we're going to switch and swipe. So what do I mean by switch? This is what I mean. You're going to take what the numerator is, which is a negative 7a, and you're going to put it on the bottom. Negative 7a. Don't change anything at all. You're literally just switching places. On the bottom, b to the negative 1 was our denominator, but I'm in the process of switching it. So now this b to the negative 1 is going to be my numerator. Again, do not change anything inside the fraction bar, just switch the places. The swipe. What am I talking about with the swipe? We switched, and we're going to swipe that negative exponent on the outside to a positive, so it's all raised to the positive 2. So watch again. I had negative 7a over b to the negative 1, raised to a negative exponent. So the first thing that I need to do is switch that fraction. What was on bottom is now on top. What was on top is now on bottom. Nothing changed. I'm going to swipe that outermost exponent that was a negative 2. I'm going to make it positive. Now we're ready to roll. This whole fraction raised to an outermost exponent, this is going to be our dissect and distribute. On top we had b to the negative 1. On bottom we had a number of negative 7. And on bottom we had a letter of a. And remember, we had an outermost exponent of 2. So this 2 belongs to everything in this problem. So I'm going to put it here, here, and here. Let's go. B to the negative 1 raised to the second exponent here. Multiply. Negative 1 times 2 is negative 2. Negative 7 squared. Negative 7 times negative 7 is a positive 49. A to the first power raised to the second. 1 times 2 is 2. All right, so far we've got b to the negative 2 over 49a squared. Now we can't have a negative exponent. Let's get rid of it. Let's move it and lose that negative exponent. So since it was on top, we got to take it to the bottom. 49 was already there. It was good down there. A squared was already there. It was perfect. But this b to the negative 2 now drops to the bottom, and we make it positive. Keep a 1 on top as a placeholder to establish that all of this should be in the denominator of your fraction. This completes our division properties with exponents. See you in class.